Today's episode is sponsored by Humtown, a family-owned global leader in the manufacturing of conventional and 3D printed sand cores and molds for the foundry industry. Visit them at humtown.com.
Aerospace and defense manufacturing.
Machines and automation.
Additive manufacturing.
Smart manufacturing.
The global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing.
Hi, welcome to another edition of SME Media's podcast series, Advanced Manufacturing Now. I'm Steve Plum, Editor-in-Chief, and I'm here today with Brandon LaMancha, Additive Manufacturing Director for Humtown Products. Thanks for joining us.
Great to be here. Thanks for having me, Steve.
So Humtown is a traditional sand casting company that formed in the 1950s, I believe.
Yep.
And more recently, you got into additive manufacturing, and now you're the biggest additive 3D manufacturer of sand cores in the world.
I mean, as far as we know, definitely in the United States. So
Yeah.
we don't have all the data out of China and some of those countries, but for the most part, yeah, we are one of the largest producers of sand cores and molds for the metal casting industry. Here in the Americas, we ship, to Mexico, Canada, California. We really have left no stone unturned here in America, as well as Brazil and Colombia, in South America. So, yep.
So I want to jump into that, but before we do, just tell us a little bit more about Humtown, its origins, and your own background.
Yeah, absolutely. So as you mentioned, my grandfather actually started the company in 1959 as a traditional pattern shop. So would make patterns and core boxes for the metal casting industry for a small radius around our location. Him and a partner started that basically in a garage, and then built it, added in pattern makers. And then in the 70s, my father saw another opportunity for the casting industry. They had two bottlenecks. One was the grinding room, and one was the core making. And we didn't want to grind castings, so he took the easier of the two, or the less dirty job, and took on the core making. So we started making cores as a consumable. We would make a core off of a die, a core box, ship that into a foundry so that they could increase their tonnage and get more castings out. So we'd done that for years. I ended up after high school started working in our CNC department. So I ran 3 or 4 vertical mills, a couple of lathes, and I made tooling for that industry. A few years went by, and I saw an opportunity with additive manufacturing, and my brother is a mechanical engineer, and I went to a few shows and looked at that technology, and I said, I think we're on to something here. So that's kind of how we kind of morph, logical progression. He actually even used some FDM plastic printing for making patterns and complex parts that traditionally would have been 3 or 4 axis machining. He was using a 3D printer to print those inserts and loose pieces. So that was kind of our logical progression through tooling, making tooling by hand, to CNC, to FDM, to then tooling lists, which is additive manufactured molds and cores.
So what was kind of the impetus to make the jump into additive? I know, obviously, the 2008, 2009 recession, I'm sure it affected you like it did all the other companies. What was the business climate like that for you?
Yeah, 2008-9, we went down from 200 employees. I think we had like 17. It was really an eye-opening experience. We didn't really see a lot of opportunity for additive there at that time, but shortly after coming out of that, we were always looking for ways. We barely got through. We had some really good jobs, some opportunities in the automotive, kept us afloat. But that did change our eye to always looking for opportunities. And a few years later, we saw this opportunity with additive manufacturing, and we said, if we can be the faster, more efficient, and get our customers what they need before anybody else, we feel like that would really give us a leg up. And that's what we saw with additive manufacturing. We didn't have delays in tooling taking 6, 8, 10 weeks. We were able to get parts in days.
So prior to making the jump to additive, had there been much change in the sandcasting industry, or was it more just incremental progress?
Yeah, it really was. I've been in the industry a long time, from, a young man after school sweeping the floors, to CNC, seeing, at the beginning of when I was using even CNC equipment, people were still making patterns by hand. So it just, I've been in an industry that I've seen is very resistant and very slow to change over the years. And I think you mentioned earlier, how we were talking before the podcast about how additive's been around for 20 or 30 years, but in the foundry industry, it's really only started to take off in the last 5. Because when I started this, even 10 years ago, I would go into foundries and I would start talking about additive manufacturing, and they thought I was, talking about voodoo or black magic, So we were very early on, in that technology, and it took a long time for the industry to start using it. Just like you said, everything has been pretty much incremental and very slow to change.
Yeah, manufacturers traditionally have been slow to adopt new technologies. How difficult was it to convince them, and what was there, certain things that pushed them over, and certain benefits?
Absolutely. What we found was, traditionally our customer was the foundry. So you have the OEM that has a casting requirement. They would go to the foundry. Foundry would come to us when they needed something, whether they needed tooling or a fixture or whatever they needed, they would come to us to produce that. But what we found with additive manufacturing was we were trying to push a technology to the foundries that they didn't want. So we had to go and work with our OEM customers that we knew that were innovative and coming up with that needed these solutions. So we started working with the OEMs, and when we went to them and showed them this opportunity, what happened was it became a demand pool. So now these foundries were being asked by these OEMs to produce castings that needed, they needed it quickly. So use additive manufacturing because you can get it in days. We need a very highly complex, casting, and we are very concerned with port-to-port variation or nominal wall thickness. And by using an additively manufactured consolidated core, we're able to get that now. So what happened was a shift from us just being a supplier to the industry to being a thought leader, working with OEMs, taking what we've learned with additive manufacturing, presenting it to them so that then they required that from the foundry. So that's what we ended up having to do.
And what types of OEMs? Mainly in the transportation industry, or?
Yeah, pretty much every industry. We've always served, castings are everywhere. Planes, trains, automobiles, space, and we've literally signed NDAs with over 300, world-class OEMs who we've helped. Like you said, automotive. We work very closely with the automotive industry, heavy truck, transportation. Caterpillar, Cummins. We work very closely with GE on energy and a lot of those companies. So for us, what's really fun for me is I get to work with all walks of life, not just one vertical, not just the automotive section.
So you mentioned FDM earlier, but that's not the process you're using now?
Correct. We started out using like a MakerBot, and then a Stratus is like a large format plastic FDM printer. But what we found was that we actually had better success in the binder jetting, going toolingless. And what we did was we skipped that entire tooling phase. So instead of printing, loose pieces or anything from an FDM printer and having to still ram the sand off of that die or off of that tool, now we just skip that. We use binder jetting, print the mold, clean it, pour metal into it, and we have a casting literally in days.
So how long would that process have taken previously?
I think of like a cylinder block or a cylinder head, a major program like that with an OEM can take months. Tooling can take, 16, 18, 20 weeks to procure tooling to produce one cylinder head or one engine block. With 3D printing, from the time we have that CAD model from the OEM of what their casting requirement is, we're able to add core prints and do what we need to do in a matter of days, print molds and core packages in a matter of a week or so, and able to take that to the foundry and get a casting in less than 2 or 3 weeks.
So now, by working directly with the OEM in some cases, are you getting involved early in the design process?
Absolutely.
And different types of designs are more flexible, complex?
One of the biggest things that, my grandfather, I wish he would have been able to see this technology, no draft. We can have backdraft, we can have undercuts without the need for loose pieces. that was one of the biggest modeling challenges. You see, an OEM would give us a casting model, and there would be no draft, no parting. So as we added the parting lines and had to add the draft, it was always a constant back and forth. Hey, how much draft can we add? This area is going to, and what that does is it increases weight to a casting or adds more machining steps and more time to process the casting. Now we literally take that model from the OEM. We just, pull the parting line, pull the cores out of the core prints. No, we never go back to them and ask about draft. And some of them we even ask, like, well, don't we have to have a design review to see where you can add draft and where you're going to do that? Nope, we're good. We don't need draft. So it really is changing.
That's a lot of trust now. Are you surprised that it progressed that fast?
It is. It really. I mean, like I said, a lot of these engineers are pushing the performance, of what a casting can do, and by having additive manufacturing as just a tool, we're not getting rid of core boxes, we're not getting rid of patterns. We're just using additive manufacturing where it makes sense. And when we do that in the right case, we're starting to see, a lot of these engineers are very happy, that we have that tool, because it enables them to produce, the exact design they want, not have what their design intent and then add draft or, do something to it that actually skews it from their original intent. So yes, they've been very receptive to that.
So what kind of volumes are we talking about?
We have some cores that we make for customers, 40, 50, 60,000 pieces a year. Could it be higher? Yes, you just have to add more printers. There is really, there is a little bit more of a cost in additive manufacturing, but as we see the equipment becoming more and more available, costs come down on the equipment. The consumables were the big hurdle, and we've overcame that about 5 years ago. We have domestically sourced, resins and binders and things that were used in the foundry industry for the past 100 years. We just had to get those suppliers. We had to get to that critical mass where we had enough volume that it made sense for them to make that in production for us.
Well, talking about volumes, I think I read somewhere that 80 tons of sand per month is shipped in.
Yeah, we're one of the, we buy it by the rail car, have it shipped in. It's really a lot of our competitors. We have some traditional competitors that we're literally printing more sand than they would blow in a core blower or a core machine. So it's escalated rather quickly. We started with America Makes and a project working with the University of Northern Iowa back in, I believe it was early 2014. We didn't get our first machine with the Youngstown State University in Ohio until 2016. You fast forward to 22, 23, we had 9 machines. Now we have 12 in one location. So, in a very short period of time, that this has really ramped up and gone commercialized.
Right, and more in the future?
Oh, absolutely. Absolutely. We have one we're setting up now over in Europe. So we're doing some printing in Europe with a partner, and they're shipping throughout the EU. So we're able to help our OEM clients in the US. They could develop a tech data package, and now we can take that same tech data package, print, pour, and have a casting, much closer to the point of need, so we don't have to ship it back and forth over the ocean. It just really reduces the time. And, we see other OEMs that are looking at setting up these centers of excellence, and, we can print for them in different countries so that when they need a casting, they can literally print it and have it cast, very close to their point of need.
So you mentioned America Makes. Describe their relationship, and obviously they're fairly close to you and location-wise.
Yep. Yeah. When a lot of this came out, early on, we didn't know where to turn. You would go to the machine manufacturer, but their main concern was selling machines. So America Makes, we were very fortunate. It was one of the first, innovation institutes, and it happened to be in Youngstown, Ohio, our backyard. So at that same time, we had seen, what additive manufacturing was doing in our industry. The printer cost at that time was well over $1 million, and our typical core machine, we would buy a core machine at an auction for $50,000, maybe $100,000 was a high-end large piece of equipment. So these machines were 10x what we were ever used to paying for a manufacturing piece of equipment. So we went to them and just kind of gave them our ideas and our thoughts, and then they put together a group of users, and then we had submitted a project called basically the acceleration of the adoption of additive manufacturing for foundries. And we had people in that project call like Caterpillar, the machine manufacturer X1, several universities, even one of our friendly competitors was on that same project call, because when we all came together and worked on this big problem together, that's how we were able to overcome the consumables and some of those major hurdles, and we were able to reduce the cost of printed cores and molds, which increased the adoption. So it was a great project. We really love to partner with organizations, universities, even our customers, because we're one company and we can do all that we can do. But when you put several people together, it's a force multiplier, and we're able to tackle these big problems for the industry.
You mentioned earlier about additive starting 35 years ago or so, and you jumping in about 10 years. It's been a gradual ramp up for the industry overall. Some not as fast as some may have predicted at some point. Did you think you got in at the right time, where it had already gotten from your rapid prototyping into some production applications, and additive used in a variety of ways, from consumer products to aerospace to medical, automotive? Was there a certain thing that you saw that said, yeah, this is how we can use it in our industry?
Yeah, we were at an event, and we saw another shop using it, and it really gave us the opportunity to look for applications where it made sense. And then we would use like the print service centers like that X1 or some of the machine manufacturers had. I still think we were pretty early, because there wasn't a lot of adoption, but I think for us, it gave us the opportunity to get in early. And then the timing of America Makes coming to Youngstown, and them partnering me with the University of Northern Iowa so I could go out there and learn without having to lay out all that capital. I think for us, the timing was perfect. And it gave us the opportunity to be instrumental in bringing this technology to the industry. Our customers, our everybody in the industry now can look at us and say, Humtown's been beside us, through traditional core making, now additive manufacturing, and what's next? We've already been looking at opportunities for direct metal printing. I think it's still a little early. Like you said, there's some really good applications. I've got to work with GE and, like on the LEAP engine for that fuel nozzle. Like that's the perfect application, for them and for that. But, you can't just go and buy one of those machines and print anything you want, and, for all these other industries, for medical or for, these other industries. So I think it's very important to understand, what you're trying to go after, whose problems you're trying to solve, and then, do it in a calculated way, because you make a few of these machine purchases that are at that price point, you lay out that capital. I've seen more companies go out of business than thriving, because it's not that the technology is bad. It's not that the technology is too early. It's just if you don't apply, your expertise and your niche, to the right technology and have the right customer support, you can only go a few months of making those, payments on these multi-million-dollar pieces of equipment before, you just cash flow out. And I think a lot of businesses have done that, because there's been a lot of hype around additive. Yeah. There's always that, there's the hype in one end, and there's the reality at the other end, and you just want to make sure that you make your right reality, in the area where it's going to be profitable, and you're able to continue.
So, how do you determine when to add another printer? Is there a tipping point? Do you have to have all the orders already in hand before you make the purchase?
Yeah, it's a delicate. There's customers and there's work that we've lost because we didn't have another printer. In our industry, we rise and fall with the purchase managers index, the PMI, there's contractions, and so we have to be really careful, because the last thing you want to do is have a few of these printers sitting around not printing.
Right.
But at the same time, we have a pretty good read on our customers, and they communicate with us, and we have a certain allotment of jobs that are just in production, so we know that those machines are going to run 24 hours a day, on production jobs, and then we leave a little bit of capacity for the emergencies. Just on the way here this morning, hey, our tooling isn't going to be ready by the time we need it. I need 100 pieces. Can you get those out? So you always have to have a little bit of that flex capacity to help out your customers in need. But it's not a science yet. It's still educated guess. Communicating with your customers, and like I said, sometimes we've probably lost some orders because in additive manufacturing, if your backlog's more than a week or so, 7 to 10 days, people are going to go elsewhere. They get so they get addicted to that speed. And if you can't perform, they're going to go somewhere else because they've told their customers. So I'd say it happens rarely, but it does, because you can never have that balance perfect.
Let's talk about some of the real world wins that you've had already in some of the applications. Anything that customers that stand out where that might have not even been realistic with traditional casting?
Yeah, absolutely. We had one project for a customer where they came to us for prototyping. They wanted to get a new product out into the market. It was an outboard marine engine, and it was going to be one of a kind. It was going to be the newest, highest horsepower engine out there. It was very exciting to be working on that project. The foundry came to us, and we prototyped it. They made castings, they made engines, performed exactly the way they wanted it to. And in the meantime, when they were going into production, they were going to build tooling. So CNC cut tooling, at a large cost, large jobs, and all steel tooling. And what happened was, because of the complexity of this core, they were going to have to assemble 3 cores, with jigs and fixtures and glue to get that core that we were able to produce as a one-piece core printed. So they did that, produced all the tooling, shipped the tooling in. We blew the cores, we shipped the cores. They were all scanned. They were all right within tolerance. Well, the problem was when they went to assemble those cores and put them in the mold, the cores, they could not get them to hold geometric tolerance. So they were making bad castings. So this, the OEM calls the foundry and says, "Hey, you gave us 50 of these. We've sold hundreds, if not thousands, of these engines based on this. We need these castings." And they said, "Well, how did you get us to 50? And they said, "Well, we use 3D printing." So they called them up and they said, "Use 3D printing." So we've made 4,000 or 5,000 of these a year ever since. And that tool's probably long. It's either mothballed on a shelf somewhere, or they melted it back down, because it just, tooling was not the way to make that part. So that for us was, it was a win, and it helped us, realize that we're turning the page from NPI, like new product introduction and prototyping, which is what the advent of this technology really was for. And now we're in full production. I mean, we have, dozens of jobs that are full production. There is no tooling for it. The customer gets a casting order, we get a printing order, we print it, we ship it, they cast it, and the customer's happy. And for me, that's the biggest win out of seeing all this go from, early on prototyping to now full serial production.
Interesting that the prototype actually sold the production contract and drove the production contract.
It drove it. Yeah. Yep.
So additive, still a fairly new technology, and not a lot of people that are experts in that area. A new generation coming up. I know employee development and workforce development are important to Humtown.
Absolutely.
And you have, I believe, students leading student tours at your facility.
Through the lens of my friends.
Yeah, can you talk a little bit about that?
Yeah, so my father is very passionate about education and the next generation of workforce, as am I. But to the extent that he was actually appointed to the Ohio State School Board by the Governor Mike DeWine. And it's very important to him that we have a future in workforce, and that people are passionate and engaged about their career. Anybody can do a job, right? But I mean, if you have somebody that's really that lights up and is passionate about what they get to do, that's really important to my father and to me. And so what we've done is we've partnered with a lot of the local schools. Education is about them understanding what opportunities are out there. I mean, when children are young, they see on TV, I want to be a lawyer, a doctor, an Indian chief. They don't know, there's only so many things they're exposed to. So what we wanted to do is we wanted to have career exposure. So we go out into the schools and we bring in everything, I believe it like 4th grade through high school, through 12th grade. We'll bring in any of the teachers that want to bring their students in. And one of the most successful programs that we've done is on our YouTube channel. You can see Riker basically, and Michaela, I believe, they brought students in. Well, they actually brought Riker and Michaela in first, showed them how to run the printer and how to do the software side, and get them trained up on it. And then about 3 or 4 days later, their classmates, their peers come in, and we have student-led tours where Riker and Michaela show them how they do what they do. And I mean, I can give tours all day long to students, and they're gonna be like, okay, yeah, that guy doesn't know what he's talking about, or whatever. That guy, that's just what he is. But when they see their peers running, $1 million 3D printer producing product, it changes their perspective, and they say, if he can do that, I can do that, and that's pretty cool. One of the unrealized benefits of doing that was we now have some of these students' parents that have come and applied because the students went home and told their parents how cool the opportunity was, and now we've gained not only the next generation of workforce, but we're actually getting some workers right now. So we have a really good team, and and some of those team members have actually come through their student-led tours. So but that's what it's about. It's about career exposure and showing them the opportunity that are out there right in our neighborhood. They don't have to go off to another country or another city, or they can have a high-tech job right in their backyard.
So what do you see what's coming next for AM and sand casting as you go? I don't know if you were at Rapid Plus TCT this year. I know that's where you kind of originally sparked the idea. But as you see other applications across various industries, and is it a continual improvements?
Yeah, I think we're going to see machines. That I was just over in Europe and Asia looking at all the machine manufacturers, who's making the machines. I think we're going to start seeing some innovation finally in the machines. I mean, you come into our facility, we have 12 of these machines. Some of them are 15 years old, some of them are today years old, and there's not much change. When we tour, people are like, well, what's the difference? Not a whole lot. So they needed to have some reinvestment. I mean, there's been acquisitions, there's been mergers, there's been like Vauxhall delisted, and so there's been a lot of things happening in the industry. But what we need to see is investment in this technology, and we need to see faster machines that are able to produce more volume for the industry. And I think there's an opportunity in the foundry industry to really engage with direct metal printing. I think there are parts out there, we call them cats and dogs in the foundry industry. You have a machine that's 30 years old, that Caterpillar or John Deere, they still want to support, that asset, but, to have the tooling and to be, in the government for crying out loud, have 1 million patterns, stored, and, there are applications for direct metal printing. We can't print everything, and we're not going to, but I think we need to embrace, the fact that we have this technology now, and for these parts where we need a one-off or very low usage, that we say, why even 3D print a mold and core package when we can literally just print that one part we need. So I think that's kind of the next phase is, we've always said, we've had tooling, now we're using toolingless, and there will be a time where in some areas, some parts will be foundryless. So literally, in my opinion, I think foundries should embrace that, and foundries should have that direct metal printer because, they have all the metallurgy, they have the background, and they also have the downstream post-processing as well as inspection technologies. So that's kind of where I see things heading in our industry. But it's going to be an exciting ride. I'm excited to see where it does go next.
We're at FabTech in Orlando 2024. What brought you here, and what did you see?
We're very excited just to see SME, and sit down and talk with you, or we'll walk the floor and see what else is going on here at the show.
Did you expect AM to be here?
Yeah, it doesn't have as big of a presence yet, but I think it's all there's so many shows and so many things, but I'm excited to walk and really see. I didn't get much time yet on the floor, but I'm excited to see who is here, and who are those early ones that come first, and see what they're having to offer, and see what the attendance is like at the booths, and see, because what, like we talked about earlier, you have traditional manufacturers here to look at traditional manufacturing machines. Are they going to, just like IMTS and some of these other shows, we're starting to see additive come in, and we're starting to see some excitement and some exposure. So it's always good to see additive right alongside good traditional manufacturers.
Right. Well, thanks for joining us today. If people want to learn more about Humtown, where can they go on the web?
Yeah, www.humtown.com. My name is Brandon LaMancha. They can email me, call me, and I'd love to help them on their additive journey.
All right, thanks. And to learn more about SME and other manufacturing technologies and other podcasts, visit us at advancedmanufacturing.org.